Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 10.3 entitled Special Products of Polynomials. And today we're going to talk about what those special products are, and this is all related to when we multiply polynomials, which is what we were discussing in section 10.3. I'm sorry, 10.2. So if you want to look at some basic multiplying of polynomials, go back and look at the 10.2 notes. But sometimes when you multiply binomials, a binomial times a binomial, you get a special pattern that happens when you multiply them. And sometimes if you learn to recognize these different patterns, it can help you multiply them quicker and easier. So we're going to take a look at a couple just basic binomials that we're going to multiply. And remember, we're going to FOIL here, but again, FOIL is really just distributing. Okay? So just think of this as double distribution. Okay? And we can use any of our multiplication methods that we want. We could use the horizontal method, which is very similar to distribution. So that tends to be the one that's preferred. We could use our vertical, we could use our lattice or our box. But I think it's easiest just to demonstrate with the horizontal multiplication method. So I'm going to take my first term times the first term in the second set of parentheses. So x times x gets me x squared. And then my first term times the last term will be x times negative 3, so that's negative 3x. And then I have to take the 3 times each of them. The 3 times the x will be 3x. And the 3 times the negative 3 will be negative 9. Now you should notice that we have some like terms here in the middle to combine together. And usually when we FOIL or do this double distribution with our horizontal multiplication, we do get those like terms in the middle that will combine. So here we have a negative 3x and a 3x, so those actually go away. So you just end up with x squared minus 9. Okay, so that's one observation there, that the middle terms go away. Okay, that's an observation for here. Now there's another special name for this type of a binomial, this x squared minus 9, so we'll talk about that in a moment. Now let's take a look at our other multiplication here. Now this type of multiplication is written in a little bit shorthand. We have the x plus 5 squared. So remember, when you have something squared, that means you have 2 of those terms. So we have to rewrite this one as x plus 5 times x plus 5. And usually that's what students forget. They want to try to distribute the 2 to the x and to the 5, but we can only do that if we had 5x squared. Then we can distribute the 2 to the 5 and the x, because there's multiplication going on between the 5 and the x. Here there's addition going on. So we can't do this operation here where we're distributing the exponent when there's addition. So we have to write the whole binomial again. And then we can FOIL. So x times x squared. X times 5 is 5x. Then I'm going to take the 5 times the x, so that's another 5x. And 5 times 5 is 25. Now here again, I have my middle terms that I can combine together. And this time they don't cancel. This time they actually double. Okay, so that's our observation here, is that those middle terms, or the middle term, is double the number that we started with in the parentheses. So I had an x plus 5, and then here I end up with 5 times 2, which is 10, and then 5 squared, which is 25. And that happens as well if we had the x minus 5 squared. If we did that, that would be x minus 5 times x minus 5. And I'd end up getting an x squared minus 5x, and then another minus 5x would be minus 10x plus 25. So we still get double that number. Negative 5 times 2 is negative 10. Now notice up here, I kind of wrote over it, but we started with a plus, and here I have a plus 10. Here I started with a minus, and now I have a minus 10. So that sign that's in the parentheses goes with the middle term. So if it's a plus in the parentheses, then we have a plus, whatever that number would be. Oh, over here, the pluses. So here we have a plus 10. If it's a minus, then we're going to have minus. Okay? So again, these are some patterns that are always going to happen with this type of multiplication. And again, these products have special names. So that's what we're going to get to next. Okay? The first one that we saw was the sum and difference pattern. That's where we had one term that had a positive sign and one term that had a negative sign. So we had x plus 3 times x minus 3. So we had x plus 3 and x minus 3. And we ended up with x squared minus 9. So it's always going to be a minus because one is a positive and one is a negative here. The middle terms cancel also because this is a positive 3 and this is a negative 3. And when you add them, you get 0. And when you multiply them, you get the negative 9. Okay? And this is also called a difference of two squares. That's going to be important to know. That's probably a better name than the sum and difference pattern because the difference of two squares is what we're going to call it when we factor it. So when we factor it, that's where we take this subtraction of the binomials, or this subtraction of the monomials, I guess. We take this binomial and we factor it, and we go backwards, and we write it as this multiplication of two binomials. Okay, so that's coming up later in the chapter, so it's good to know now that this is the difference of two squares. It's a difference because it's subtracting, and it's two squares because this is x squared, and this is really 3 squared. 3 squared is 9, so this number is going to be a perfect square. Okay, for our square of a binomial, we also took a look at those. We had the x plus 5 times x plus 5 on the previous page. And we got x squared plus 10x plus 25. So like I said, we had double that number in parentheses. So they write it as a squared instead of x squared. And then we have 2 times a times b. And then we have b squared. So we have 2 times x times 5. X and 5 would be our a and b. So 2 times x is 2x times 5 is 10x. And then we have the b squared. That's the 5, so that would be the 25. And then we took a look at this with the minus as well. We did the x minus 5 times x minus 5. And we got x squared minus 10x plus 25. Now notice there's no x squared plus 10x minus 25. You could have a minus and a minus, but you're not going to have a minus and then a plus. Okay? So knowing that you can have a plus plus or a minus plus, that's an important part of the pattern as well. Okay, so for this next example, we're just going to take a look at whether or not some binomials or some expressions fall into one of these patterns. So in example 1 here, we want to tell whether or not the expression is a difference of two squares. So that means it has to be a difference. We have to be subtracting. And it has to be x squared, and then the next number has to be a perfect square. So 4, 9, 16, 25, 36, 47, I'm sorry, 49, and so on and so on and so on. So x squared plus 25, that's not a difference of two squares because they're adding. That would be a sum of two squares. So no, this one's not a difference of two squares. So part B is a difference, and then our first term is x squared, and 4 is a perfect square. So yeah, we actually have a difference, and both of our terms are squares. So yes, this is a difference of two squares. And then C, okay, that's a difference because we're subtracting. We have an x squared. Oh, but 32 is not a perfect square. Now, if it had been 36, then we would have had a perfect square. Okay, now in example 2, it says tell whether the expression is the square of a binomial. So that was the second pattern up here. So we have to make sure that our last number is a perfect square. Our middle number is going to be double the square root of that perfect square, basically. And then we have to make sure we either have a plus plus or a minus plus for our signs. Okay, so example number 2, let's see, I have a minus plus for my signs, so that works. I have my x squared. 9 is a perfect square. So the square root of 9 is 3, and then 3 times 2 is 6. So this is double our number that would have been in the parentheses. So yes, this one follows the square of a binomial pattern. Okay, part B, I have a plus minus for my signs. We didn't have a plus minus up here. We had a plus plus and a minus plus. So because the signs are not following that pattern, no, that one's not going to be the square of a binomial. Now part C has a plus plus. That's okay. I can have two additions. So you have x squared, and I have 9. Okay, those are both perfect squares. Now the square root of 9 is 3, and 3 times 2 is 6. So I should have 6 here for my middle term, and I don't. I have 3. So no, that one doesn't follow the pattern where we need to have double that term that would have been in parentheses. Now, whether or not you can recognize these patterns now, not too super crucial. This is more just to kind of introduce you to it and get you used to looking for these patterns because it's going to help you later on when we have to factor. So if this seems a little funky right now, that's okay, but still try them. Still try to make those observations. But example 3 is probably the more important part of the notes because this is where we're going to find the product. This is where we're going to multiply our binomials together. So we're going to use these patterns. Now, again, like I said, once you get really good at these patterns, you'll be able to do these by using the rules of those patterns. So you won't actually have to do the double distribution and combining your like terms all the time. Okay, so we have A through D, and then we'll be done. Part A is 2y minus 5 times 2y plus 5. So it's the exact same thing on the parentheses, except one has a plus and one has a minus. So that's actually going to be our difference of two squares pattern. So that means I should end up with two terms that are being subtracted. So I'll have 2y times 2y is 4y squared. And 2y times 5, that'll be 10y. Then I will do the negative 5 times 2y. So that'll be minus 10y. So those two terms are going to cancel then. And then negative 5 times positive 5, that's a negative 25. So again, even if you didn't notice it as you were multiplying, Now you should see that I have two like terms that I can combine together, and when you combine them, they end up canceling. So we end up with our difference of two squares. Okay, so if you want to label that this one is a difference of two squares, that can be good to know for later on. Okay. For part B, again, this is one where students often miss it because they want to just distribute that exponent, the 3x plus 4 squared. Students want to just distribute it, and that is wrong. It's an illegal math operation. We can't do that. And again, we can't do that because of the addition between the 3x and the 4. If it was 3x times 4, then we could distribute the exponent, but with the addition or subtraction, we can't. So rewrite your parentheses 2 times, and then do your double distribution. So 9x squared plus 12x. 4 times 3 will be another 12x. And then 4 times 4 is 16. So again, this number at the end here, this is a perfect square. I'm going to have my middle terms that will combine, and they'll end up doubling the terms that I had there. So I end up with 24x plus 16. So this trinomial then is going to follow that perfect square binomial. Okay, so this is our, well, when we factor it, we actually call it a perfect square trinomial. Okay, and again, that's because this is a perfect square, the 16, and this term here, the 9 is a perfect square, and the x squared is also a perfect square. Okay. And part C, this is going to be another perfect square. I have to rewrite it, x minus 7 times x minus 7, and then multiply. So x times x will be x squared. I have a minus 7x. And here I get another minus 7x. Negative 7 times negative 7 is a positive 49. So those middle terms will combine, and when I combine them, they double. So that's what tells me it's going to end up being that perfect square trinomial. Okay, so again, this is our perfect square trinomial. Okay, now part D, again, it should look similar to A. This is very, very similar because it's got the exact same terms, except one's a positive and one's a negative. So this is going to be my difference of two squares. So I'll get 16x squared minus 4x plus 4x. So those middle terms are going to cancel. And then 1 times negative 1 is minus 1. So I'll end up with 16x squared minus 1. So again, this is that difference of two squares. So these are the two patterns that we're going to practice over and over again today in your notes. So you'll have some multiplying that you'll have to do. You'll have some identifying that you'll have to do. Okay? So get familiar with these patterns, because if you see that you have a term that's a difference of two squared, this x minus 7 squared, once you recognize the pattern, you can go right from seeing this problem to the answer in one step. Okay, so these patterns are meant to save you time as long as you recognize them. Okay, so these are the problems that you can practice today. Number 51 through 53 we'll look at together in class. They're just problems out of the book that have a specific picture, and you might need to talk about what that picture means and how to interpret it so that you can set up either a difference of two squares or a perfect square trinomial type of multiplication. Okay, so if you have questions on any of this stuff, come on in and see us before school, and definitely show your work on your homework.